Okay, good morning, afternoon, whatever, everybody. For those of you who don't know me, my name is Mr. Renard. I'm the other geometry teacher here, and doing this just to help out. So, this is the bell work problem. I don't know whether you guys have done anything like this before, but this is what's called an algebraic proof. What we're going to do is we're going to take this problem, and not only are we going to solve it, but we're going to sit there and justify each step that we do. We'll get into why we're going to do that a little bit later. So the first thing we're going to do here is distribute. So we distribute that 4, and we get 4x minus 28 plus 3x, and we have 3 times x, 3 times a. 3 plus 24 equals 10. Now when we do a proof, this is called a two-column proof, and we have steps and reasons. The first step is that it is given. Most proofs start off that way. I want to start off with what we're given, and the second one. So then we have to sit there and go, how do we get from step 1 to step 2? And whenever you're doing a proof, that's kind of like the most important question. How do you get from the previous step to the current step? So we look there, and we see that what we did was we distribute. So we're going to go ahead and say, hey, we use the distributive property. So what we're going to do next then is combine like terms. Now the book calls it simplification or simplify. You'll also see it as combine like terms, and those are used pretty interchangeably. So then, sorry about the bird. So what we're going to do is we're going to then add 4 to both sides. Now, normally we just do that, but so we actually have to sit there and call it the addition property of equality. Okay, so now we're at 7x equals 14. So we're going to go ahead and go to x equals 2. So that's the next step. That's what it looks like. How do we get there? Well, we divided both sides by 7. What allows us to do that? The division property of equality. Okay, so make sure you have that down in your bell work. Again, to get points, at least in my class, ultimately this is going to be whoever your teacher is decision, but at least copy down what's put on the board. So if you guys want to stop it for a second or just continue. So now that we're continuing, what we want to talk about is what a proof is. A proof is not just the what of a problem, but the why. Now, as you may have noticed, I have horrific handwriting. Not only that, normally I write with a stylus. I left that at school, so I'm writing with my finger tonight. So it's even worse. So a proof, and you guys should have gone over this in 2.6, is, again, not just the what, but the why. So we sit there and we write our steps down. We write what we're doing, and then we write a justification for it. It's not enough just to sit there and say this is the step we take. We actually have to sit there and say, why do we do it? It's something that a lot of people have difficulty with. It's something that most sane people can't stand. But it is probably the most difficult thing you'll learn in geometry, and also the most useful thing you'll learn because of the attention to critical thinking. So, a quick switch over. So you're going to be given a worksheet. It looks like this. It says 2.6, Form G on the right. It won't be in a Word document clearly. But what we're going to do is I'm going to do problems 1, 2, and 3 with you. Now problems 4, 5, and 6 are all the same type of problems, but I want you guys to work on those by yourselves. So I'm going to do 1, 2, and 3. Then you guys do 4, 5, and 6. Now notice that they are all of them, each and every one of them, vertical angles. So when we start working on it, we know that vertical angles are congruent. That's the vertical angle theorem. You guys should have gone over this. So we set it up. We know that congruent angles have equal measures, so we can set it up as 5x equals 150. We're then going to divide both sides by 5, and we get x equals 30. Are we done? Do we have to go back, plug the x in to make sure? No, all we have to do is find the value of x. So moving on. Again, we know that those two angles are congruent, which means their measures are equal. So we can just go ahead and set them equal to each other. So we get 3x minus 40 equals 2x minus 10. So in case you don't remember what a vertical angle is, the technical definition is an angle formed by two sets of opposite rays. So opposite rays are same vertex heading in the opposite direction. So if this is our angle that forms that 2x minus 10, and I were to draw the opposite rays from those two that form that angle, I'd end up there. Now I also like to call them, and if you guys know me, my bow tie angles. These vertical angles form a little bow tie. So that's how you know. So if it looks like a bow tie, which is totally cool, then you can go ahead and say that they're equal to each other, as long as they're on that opposite side. So they've got to be here and here, right? Can't be here and here. Those are going to be supplementary, equaling 180. So there you go. So we're back now, and we have 3x minus 40 equals 2x minus 10. We're going to subtract 2x from both sides. It's going to give us x minus 40 equals negative 10. We're going to add 40 to both sides, and we get x equals 30. Now, even though we're done, I just want to show you how you do this if you were asked for the measure of the angle. What you do is you'd go ahead and plug that 30 into both of these, and knowing that they're congruent angles, they should match up. So this one right here, 3 times 30, that's going to give you 90. 90 minus 40 is 50. Over here, 30 times 2 is 60. 60 minus 10, also 50. So because they match up, you know you did it right. So number 3, we have 3x plus 6 equals 90. We subtract 6 from both sides, we get 3x equals 84. Divide by 3, and we get x equals 28. Okay, if you're having difficulty with these, ask Miss Sweezy, whoever the sub is, to rewind it and rewatch these again, get the hang of it, move on, try 4, 5, and 6 by yourself. Okay, so now we're getting to 7, 8, and 9. Now 7, 8, and 9, basically the same idea. We look over there, and we see that 1 and 4 are vertical angles, and that 2 and 3 are vertical angles. So when we're sitting there and looking over at the problem here, notice they give us vertical angles, vertical angles, vertical angles. So all they're really asking us to do is set those equal to each other. So for number 7, we'd go 5x, that's the measure of angle 1. And we know that the measure of angle 1 is equal to the measure of angle 4. So we go 5x equals 2x plus 90. Subtract 2x from both sides, and we get 3x equals 90. And then you divide both sides by 3, and we get x equals 30. Now it says find the measure of angle 1 given the information. So we're going to plug 30 back into here. And that's going to give us the measure of angle 1 equals 150 degrees. Now the only thing different here is that when we get down to the measure of angle 2, we know that the measure of angle 2 is supplementary to angle 1. So when you get to the measure, when you get to number 9, keep in mind that the measure of angle 2 plus the measure of angle 1 equals 180. So what's going to happen is you're going to use these two, set them equal to each other, solve for x, plug back x back in, and that's going to give you the measure of angle 2. You then subtract that number from 180, and you're going to get the measure of angle 1. Why don't we just go ahead and... yeah, never mind. If you guys need help, just have your sub quick email me, and I'll walk you through the steps. So this now is number 10, and this is what I was talking about earlier, a proof. We're given the fact that angle A, it's this one right here, is congruent to BDA. That's this angle right here. So what we want to do is prove that x equals 5. Well, how are we going to do that? Well, lucky for us, they have the vast majority of the proof set up. All we have to do is go ahead and fill in the blanks. So, first things first. It says given. Well, we look up there. We are only given one thing, so we're going to put that down. So we get B, measure of angle A, equals the measure of angle BDA. That's the given, okay? So all of these should read like a conditional when you're done. So when we're done, we should be able to say if angle A is congruent to angle BDA, then x equals 5. So you should have that if-then setup of a conditional. So we have angle A equals angle BDA, or is congruent to. Sorry, not equals, congruent. That's given. So next we look at that vertical angles are congruent. Well, we only have one set of vertical angles here. Those are circled over there. So it's BDA and CDE. And we know, as we just talked about, vertical angles are congruent. So that's set up right there. So now we have A is congruent to BDA. BDA is congruent to CDE. And so that we can use to say, now that we know those two things, the measure of angle A is congruent to the measure of angle CDE. Okay? And that is the kind of textbook definition of the transitive property of congruence. Notice that since we're dealing with congruent figures, we're not going to use the property of equality, but rather the property of congruence. So the next step, we see that it has the definition of congruence. Well, whenever you see the definition of congruence, or the definition of supplementary angles, or the definition of complementary angles, definition of a linear pair, anything like that, those are the things that we as mathematicians use to switch from congruence to equality. Because if we look down at step number 5, you see we got a bunch of variable terms and numbers and constants, and we got an equal sign. So 4 is where we move over from the congruent sign, that's the equal sign with a squiggly on top, to the equal sign, which is just, well, the equal sign. And we're going to do that with the definition of congruence. And we know that congruence means, the definition of congruence is that congruent angles have equal measures. So what we're going to do is we're going to look at step number 3. We see that step number 3 says the measure of angle A is congruent to the measure of angle CDE. So we're going to go A is congruent to CDE. So we're going to use the definition of congruence to say that the measure of angle A is equal to the measure of angle CDE. Sorry about that. So we then look at how we got from number 4 to number 5. What changed? Well, instead of angle A, we have 11x plus 20. Instead of angle CDE, we we have 12x plus 15. So what we did is we switched them out. When we ever do that kind of switcheroo, that's called substitution. So the subtraction property of equality. Now there are really two ways you can go here. You can subtract 15 from both sides, or you can subtract 11x from both sides. I always like to start off by getting my variables together. So I'm going to subtract 11x from both sides, and that's going to give me 20 equals x plus 15. And then last step. Now if I look up top, I see that I'm trying to prove that x equals 5. Okay, and I'm on my way to doing that. I'm not worried about it. But I'm trying to prove that x equals 5. Now in trying to prove that x equals 5, my last step then should always be what I'm trying to prove. Okay? So if you can look up, I could have looked back at this at the very beginning, looked down at number 7, seen that it was my last step, and filled in x equals 5. The reason I can do that is because it's the last step. If I'm trying to prove x equals 5, well then as soon as I prove that x equals 5, I'm going to stop. I'm not going to keep working. And I do that, as I just saw, by subtracting 15 from both sides. Okay, so just a reminder, you guys aren't supposed to be watching this straight forward to back. Try and work these out by yourself. Give it your best, college try, as they say. I don't know who they are, but they say that. I've heard them. And then only if you guys can't do it, then whoever the sub is can go ahead and hit play. I'll walk you through the problem. Then you can go back and try and figure out the other ones on your own. Okay, so let's look at number 11. We got another proof. How exciting. I know we all love proofs. We got 2 more to go, so everyone's just like throwing parties, balloons, unicorns, the whole shebang. Okay, so here's the thing with 11. Because of the transfer from the documents and different Word programs, it's not actually angle 5 is greater than angle 2. It says angle 5 is congruent to angle 2. And we need to prove that 8 and 4 are congruent to each other. Okay? So, again, we start off with our given. We look down at step number 1. We see that it says given, so we're just going to fill in our given. Angle 5 is congruent to angle 2. Okay? Well then, the next step is angle 2 is congruent to angle 4. How do we know that? Well, we look over at the diagram and we see that they're vertical angles. We know that vertical angles are congruent by the vertical angle theorem, so that's what we fill in. So next, we have to fill in the step, okay, or the statement. Now our justification here is that it is the transitive property of congruence. So it helps to know your vocab here, guys. If you don't know what the transitive property of congruence is, you're stuck. If you know that the transitive property of congruence is that if A is congruent to B and B is congruent to C, then A is congruent to C, which it is, then you can look at steps 1 and 2 and go, hey, I've got 5 being congruent to 2, 2 being congruent to 4, so we can cut out the middleman, and we get 5 is congruent to 4. And that is the transitive property. Since 5 and 4 are both congruent to angle 2, they have to be congruent to each other. Think about it this way. I know that 8 times 4 is 32. I also know that 48 minus 16 is 32. So I've got 2 things that are both equal to 32. And that must mean that they are equal to each other. So 4 times 8 is equal to 48 minus 16. That would be the transitive property of equality. Same rule applies here because 2 is congruent to 5 and 5 is congruent to 4. We know that 5 and 4 or 2 and 4 are congruent. I got that backwards. 5 and 2 are congruent, 2 and 4 are congruent. Ergo, 5 and 4 are congruent. So, we then look at the next step. Now, this is tough here, and I'll admit, this is kind of tricky. This takes a little bit of a leap of understanding. So, we have vertical angles are congruent. Well, the fact is, we got a bunch of vertical angles over there. We already did 2 and 4, but 1 and 3 are vertical angles. 5 and 8 are vertical angles, and 6 and 7 are vertical angles. So what we really need to do is go, which angles are we trying to relate to each other? So right now we're sitting at 5 is congruent to 4. Step number 5 says that 8 is congruent to 4, and that's what we're trying to prove. So we somehow need to make that jump from 5 is congruent to 4 to 8 is congruent to 4. Well, wouldn't it be lovely if we could somehow connect angle 5 and angle 8? Well, we know that vertical angles are congruent. We look there and we see that 8 and 5 are congruent, or vertical angles rather. So we can put down that angle 8 is congruent to angle 5 because vertical angles are congruent. Now we're going to double dip on one we've already used. Notice there's a pattern here. There's nothing that says in a proof you can only use one rule once. This isn't like a word match game from 4th grade English, okay? If we have to use the same thing 10 times in a row, we'll use the same thing 10 times in a row. We're mathematicians. We can do that. So what we want to do is we want to sit there and look and go, okay, we go from 5 is congruent to 4 to 8 is congruent to 5. Therefore, 8 is congruent to 4. So again, look at what we did. We're cutting out that middleman, basically doing the exact same thing we did to get from step 1 and 2 to step 3. So now we're using step 3 and 4 to get to step 5. And that is the transitive property of congruence. Okay? So that's our proof. I know it's tough. It requires a pretty in-depth knowledge of the vocab. I don't know what your rules are on like theorems and stuff like that, but you guys got to know this. You guys got to write them. You guys got to have somewhere where you can go and check all your theorems in the same place. I make my kids keep a theorem bank, and those that do seem to have a much easier time with proofs. Okay. Last, and certainly not least, is the dreaded paragraph proof. Now, paragraph proof is basically the same thing as a 2-column proof, except it's written in sentences. Now, about 80% of you are going to sit there and go, why on earth would we ever have to do this? The other 20% are going to go, oh my gosh, this makes so much more sense. For those of you who are wondering, and I know that's all of you, these make more sense to me. Because I can just write down what I'm thinking, and then I'm done. And that's kind of awesome. Instead of kind of the very formulaic left, right of a 2-column proof, I just get to write down what I'm thinking. And when I've ended up proving what I need to prove, I'm done. So, let's get this out of the way. So we know that blank and blank are complementary, and 2 and 3 are complementary because these facts are given. Let's look up at what our given facts are. It's that 1 and 2 are complementary, and that 2 and 3 are complementary. The fact that 2 and 3 are complementary is already down there, so we can fill in 1 and 2. By the blank, the measure of angle 2 plus the measure of angle 3 equals 90. Well, how do we know that if two angles are complementary, then their measures add up to 90 degrees? Well, that is the definition of complementary angles. Whoa, went a little bit farther. That is the definition of complementary angles. So you guys know that is not like some weird check thing. That is the angle sign with an S inside of it, and that is read angles. That is a legitimate shorthand because mathematicians are lazy and we don't want to write more than we have to. You'll see it in the book. That's how you write down angles. So, next step. Given that BD bisects ABC, it follows that blank. Okay, now here's the thing. We have to know what bisects mean. Bisect, well, we know that the prefix bi means two. Think bicycle, two wheels. And it bisects ABC. So it cuts angle ABC into two equal parts. Okay, so what does that mean? Well, if we look there, we see that angle 2 and angle 3 are there. So we can say that the measure of angle 2 is equal to the measure of angle 3. Okay, so if we know that BD bisects ABC, that's given right there, then we know that angle 2 and angle 3 are congruent, which means they have the same measure. Using substitution. Okay. So what we're going to do now is we're going to take this equation right there that we just had, 2 plus 3 equals 90. And we're going to substitute out the measure of angle 2 for the measure of angle 3. So we have the measure of angle 3 plus the measure of angle 3 equals 90. So notice we took the fact here that 2 and 3 are equal to each other. We coupled it with this equation and we switched out the measure of angle 3 for that right there. Because I know they're the same angle. They are created by a bisector. It means they're equal. Okay. Or 2 times the measure of angle 3 equals 90 degrees. Using the blank, we get the measure of angle 3 equals 45. Well, how do we go from here, 2 times the measure of angle 3 equals 90, to here, the measure of angle 3 equals 45? Well, we divide it by 2, so we're going to call that the division property of equality, or as I like to shorthand, div-po. Now notice, up top I just talked about how angles are a legitimate shorthand. POE for property of equality is not a legitimate shorthand. If you write that down, no one's going to know what you're talking about. So, by the congruent complements theorem, blank. Well, again, it helps to know what the congruent complements theorem is. If you don't know what the congruent complements theorem is, you're kind of stuck. So we'll go flip through the book, find the congruent complements theorem, and it says that if two angles are complements of the same angle, then they are congruent to each other. So if 1 plus 2 equals 90, and 2 plus 3 equals 90, then 1 and 3 have to be the same angle. Okay, and here we have that. We have 1 and 2 are complementary. 2 and 3 are complementary. So we have 1 and 3 are both complements of the same angle, so therefore they are congruent. Angle 1 is congruent to angle 3. It follows that the measure of angle 1 equals the measure of angle 3 because congruent angles have the same measure. That is the definition of congruency, and you'll see it written both ways. I've heard it both ways. So, and blank by substitution. Well, here's our last thing. So again, we are trying to prove right there the measure of angle 1 equals 45. We've already proven that 3 equals 45 right there. Sorry, that was supposed to be highlighted. It was going to be so much more impressive. There you go. Ooh, ah, yep, amazing. Measure of angle 3 equals 45. We then proved that the measure of angle 1 equals the measure of angle 3. So therefore, the measure of angle 1 equals 45. That's a substitution. We know 3 equals 45. We know 1 equals 3. So we switched out the 1 and the 3. Feel free to come by my room with any questions you guys have. Other than that, watch them again. This is on YouTube. I know you guys are all so excited about learning this stuff that you're going to go and watch this video like over and over and over and over again. But I hope this helped, and be nice to your sub. Thank you guys very much.